Hi there. This is Marissa May, and I wanted to go over the week 4 discussion with you. Actually, the week 4 discussion number 1, just to kind of get your brain thinking along the lines that you're going to need in order to write a great discussion post for this week. So let's take a look at the prompt to begin with. You're working with an employee, Juan, who just started as an operations manager at the new job. His mentor is actually reviewing some of the data that they process through in his line of work. And the mentor expects that Juan already knows how to interpret this data. So we're asked to identify, what are the risks if the graphs are done incorrectly? And what if Juan is not up to date on this information? So let's take a look. I think it's worth our time to look at ways that we can misread a graph. One way that I think that you're going to find we see a lot that happens is that the numbers don't add up. Let me show you a graph to show you an example of what I've seen before. Take just a moment to look at this graph here. See if you can figure out what's going wrong. I think you might have found it, right? We have this beautiful circle graph showing us how voters were feeling about potential candidates. And yet, look at your percentages. You have 63, 70, and 60. I thought the percentages were supposed to add up to 100, right? So that's one way that a graph can be very misleading, is that if 63% of the people liked Palin, then, 63 liked Huckabee and 70 liked Palin, how are these two not related? So we have to be very careful with that. Okay, second way that we can misread a graph, that it doesn't follow the naming conventions we have for graphs. So take a minute to look at this graph. See if you can pick out what's not exactly right. I don't know about you, but that point right there, the 2005 is over the 2000s. That doesn't seem to line up, does it? I almost think the 2005 should be somewhere a little bit to the right. So this here is actually not for a point at 2000. So we have to be really careful that we use graphs that actually have naming conventions that are similar to what people are accustomed to with other graphs. Okay, let's take a look at the third way then. And that is cropped axes. Take a look at the graph I have here. Now, if you look at this graph, you would initially, not looking at the numbers, you would think there's a big difference between March 27th and March 31st. But now take a look at the numbers. You have 6 million compared to 7,066,000. Another way that probably would be better to write or show this particular graph is if we make the graph a little bit more representative. Notice that the 6 million, when we put labels on the axes, the 6 million actually looks in comparison to the 7 million. Yes, there's still a little bit of ways to go to get to 7 million, but it's not way down here at the bottom like the previous graph was. So I hope that helps you come up with some ideas about how Juan can make his graphs, and he can avoid the risk that might be associated with some of these errors with reading a graph, but also to think about how Juan can keep up with his skills and not get into some of these errors that we see in solving and reading graphs.